Alright guys, in this section we're going to be discussing law of sines. This is one of the laws that we'll be using to solve oblique triangles, and we'll define what those are. Alright, so we're going to have four cases here of triangles or setups, and to solve an oblique triangle we're going to need to know the measure of at least one side and any other two measures of the triangle. Either two more sides or two angles or one angle and another side, but we need to have at least one side. This first two cases, so angle angle side or angle side angle and side side angle, are going to be solved with law of sines, so that's what we're going to be looking at in this section. And on the next section we'll look at how to solve the other two cases, side 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 and side angle side, with law of cosines. So you're only going to be able to use one of these laws at first anyways to be able to solve these cases. Now first we're going to define what oblique triangles are, and these are just triangles that have no right angles, right? So far we've been looking at how to solve problems or word problems using a right triangle with right triangle trigonometry. We're going to look at all the other types of triangles, and oblique includes all of those. We're going to have two types, acute and obtuse, as you see in these two pictures here, right? Acute just means that all the angles are less than 90 degrees. Obtuse is that you're going to have one angle that is more than 90 degrees, right? As you can see it on the angle A here. Now our convention here is going to be labeling the angles with capital letters A, B, C, and the opposite sides to them are going to be labeled by the lowercase letters A, B, C still. So you see angle A is opposite to side A, angle B opposite to side B, and angle C to opposite to side C. Whether we have an obtuse or an acute triangle, we're going to have that same standard notation. All right, so then law of sines and law of cosines are going to help us find or solve for these oblique triangles, in the sense that we'll be given some information, some sides, some angles, and we'll be asked to find the other ones. Now we're going to start with law of sines in this section, and the derivation is pretty straightforward. So if you look at either one here, I'm going to just look at the acute triangle here on the left, but it works just as well for the obtuse triangle. If we look at sine of A, and notice how there's a height there, h, right? If you look at the right triangle there, the small one, you can set up sine of A as h over b, and so for h, and get b sine of A. We're going to leave it like that for a minute. Same way we can do sine of b. Look at the other right triangle within our triangle ABC, and set it up as h divided by A. And we solve for h, just like we did on the other one. We get h equal to A times sine of B. All right, this h on both equations is the same h, the same height from the triangle. So we can just set those two equal to each other. We get b sine of A equal to A sine of B. Okay, so moving some things around, I'm going to move lowercase a to the left and then lowercase b to the right. And I get sine of A over lowercase a is equal to sine of B, angle B, divided by lowercase b. Now remember what these capital letters and lowercase letters represent, right? One capital letters are angles, lowercase letters are sides, the opposite sides to be specific. So literally we have sine of an angle divided by its opposite side is equal to the sine of another angle divided by its opposite side. In the same way we can prove or derive for the angle C. Just for the sake of time, we'll just write it in here. This will also be equal to sine of C divided by lowercase c. And there we have it. That's our law of sines. Now we're going to look at this, how to apply this law in an example. And we have here for a right triangle here where A is 30 degrees, B is 45 degrees, and lowercase a, in other words, the side opposite to angle A, is 32 centimeters. Find the remaining angle and sides. So when you ask, later on you may see this question as solve for this triangle. What that means is finding the remaining sides and angles here. That's what it means to solve an oblique triangle. And here notice how right away we identify this as angle side. and just labeling everything that I have there. You can see it from the picture. I have two angles in a side, and so this is law of sines is going to apply here. So we have our law here, and you're not going to use, you have two equations here, so you just use whatever applies. In this case, I have capital A, capital B. The first thing I can figure out right away, since I know the sum of all three angles on any triangle is 180 degrees, I can figure out the third angle by subtracting the first two angles that are given from 180 degrees. So we get that 180 minus 45 minus 30 is equal to 105 degrees. So this is my third angle, angle C. So that was pretty straightforward. We didn't have to use the law of sines to figure that out. It's just a basic fact from geometry. The sum of three angles on any triangle is 180 degrees. Now we're ready to use our law of sines, and we set it up by doing sine of A over A is equal to sine of B over lowercase b. Now for us, angle A is 30 degrees, so sine of 30 over 32 is equal to sine of 45 over psi B. We solve for B, lowercase b, and we get that b is equal to 32 times sine of 45 degrees divided by sine of 30 degrees. All right, just putting this in the calculator, we're going to get that b is approximately, and we're going to have to round, and we'll just round to 2 decimal places here, 45.25. This is centimeters because we just figured out psi b. All right, so that's psi b, 45.25 centimeters. And now all we have left to find is side C, little c. Now remember, we already know what angle C is, 105 degrees. So we set it up by doing sine of A over A equal to sine of C over C. And that's, for us, sine of 30 degrees over 32 equal to sine of 105 degrees over lowercase c. It's just very similar than the one we just did for lowercase b. This is just a different angle on a different opposite side. So then solving for c, we get 32 times sine of 105 over 30 degrees, and lowercase c, or side c, is going to be approximately 61.82, and this is centimeters as well. And there we have it. All right, here we have a word problem where we're going to have to use law of sines as well. Notice how we get a picture here. It says find the height of the tree shown in the figure. And notice how the tree is slightly slanted to one side, and it's not forming a 90-degree angle. It's not a right angle with the ground. It's actually 96 degrees. And we have another angle there, 23 degrees, and a measurement of one side is 30 meters, right? And we want to find h. If you look at the angles, we can find the other angle here, right? But this is going to be a case of angle, angle, side again, or angle, side, angle. And we can right away figure out the third angle, because the sum of the three angles is 180, so I can subtract 23, 96 from 180 and get 61 degrees. And so that I can set up my law of sines here. Since I have the side opposite to 61, I needed a 61 degrees. So we're going to set it up by having sine of 61 degrees divided by 30 is equal to sine of 23 degrees divided by h, since h is opposite to that angle, 23 degrees. All right, cross multiplying here, we get h times sine of 61 degrees times, or equals to 30 times sine of 23 degrees. Solving for h, I'm going to have 30 times sine of 23 degrees, all of that divided by sine of 61 degrees. Putting this in the calculator, we're going to get that h is approximately 13.4 meters. All right, here we have another example, and in this case, I'm given an angle in two sides. Okay, so I'm going to label A to be 12. My angle A is 31 degrees, and then side B is 5 inches. We want to solve this triangle, finding the remaining side in angles. Okay, so here I can't find the angles by subtracting from 180 because I only have one. So I'm going to have to start with my law of sines here, set it up. And this is the case of side-side angle. okay? Have two sides and an angle. So this is that second case from above, where we have 4 cases. Remember, we're gonna be able to solve the first 2 cases with law of sines. So this is the second case when we get side angle, and we set it up with just sine of A divided by A equal to sine of B divided by B. And we plug in our numbers. Sine of 31 degrees divided by 12 equal to sine of B, angle B divided by 5. Cross multiplying, and I want to find B, so I'm going to have to solve for sine of B first. And I guess 5 times sine of 31 degrees divided by 12. That's what sine of B is going to be. Now, I ultimately don't want sine of B. I just want to find what B is, the angle B is. So I'm going to have to do, or use our sine inverse here to figure out what B is. So plugging that in the calculator, we're going to have arc sine of 5 times sine of 31 degrees divided by 12. And make sure, again, your mode is in degrees. And we'll get that B, angle B, is approximately 12.39 degrees. Okay, so once I have my angle, my second angle, angle B, I can quickly find the third angle. Now I can subtract the first 2, A and B, from 180 degrees and get my third angle here. So C is going to be equal to 180 degrees minus 31 degrees minus angle B that we just found to be 12.39 degrees. And I'm rounding everything to 2 decimal places, but here, so we're gonna get the C is 136.61 degrees. All right, so we have the 3 angles, we have 2 sides. Now we have to find the last side here, lowercase c, and we can set up our law of sines again and find that. I'll use angle A, so sine of 31 degrees divided by 12 is equal to sine of 136.61 degrees, which is angle C, divided by lowercase c. Cross multiplying, we get C times sine of 31 degrees is equal to 12 sine of 136.61 degrees. And then we want to solve for C by dividing both sides by sine of 31 degrees. We're going to get the C is equal to 12 times sine of 136.61 degrees divided by sine of 31 degrees. Okay, so putting this in the calculator, we're going to get that C, the size C is approximately 16.01 inches. Okay, there we have it. Okay, so here's another example of the same case. We're going to have 2 sides and an angle, but we're going to show here on this particular example how there's actually no solution. And I just have this picture. I'm using the same picture here of the same ABC triangle, but don't get fixated on that. This is not drawn up to scale. It's just an aid for us to be able to visualize what, where the opposite sides are and what angles we have and what case we have, right? And make sure we keep track of what we're finding. But this is by no means what is representative of what we're finding here. Like the previous example, notice how one of the angles was obtuse. So don't follow the picture. The picture is just an aid to see which one is opposite to which angle we're trying to find, which ones we have. Okay, so it's just a template here. But it turns out here for this example, if we set it up, right, we got to find angle B first, set it up with what law of sines. Sine of 60 over 4 is equal to sine of B over 14. Cross multiply, solve for sine of B, just like we did on the previous example. We get the sine of B is equal to 14 sine of 60 degrees over 4. And before I can do the R sine here to find B, I realized that this quantity right here is, if I put it in the calculator, it's like 3.03. But the point is that it's more than 1, right? And remember, the range of sine is from -1 to 1, so I'm not going to get anything above 1, positive 1, and this value is more than 3. So therefore, doing the R sine is not going to give us anything, or there's not going to be any solution here. This will be undefined. What does that mean for us here? If there's no solution, if I can't find that angle B, what that means is that given these measurements here, right, the two sides and that angle, I'm not able to construct or form a triangle with those measurements. One side would be too short, so cannot be formed here. In other words, this triangle doesn't exist. We cannot construct this triangle with these measurements. Okay, now here's another example of the same case. Right, we're still in the case of side-side angle, but now in this example we're going to have two solutions. So notice how we've seen the previous two examples. One of them had one solution, the other one had no solution. Well, we're going to have a case where there could be a two triangle solution here. In other words, there'll be two different triangles that can be formed with the given information here. So I'm not going to have the picture anymore. I think you get the idea. And since we're going to get two different triangles, we'll just set it up, figure out the remaining angles and sides, and then we'll talk about how the triangles look like. We're setting it up. Right? Every time you get this case, angle, side, you got to start by finding that second angle. Right, whatever angle is opposite to one of the given sides there. So we set it up, a sine of 58 degrees divided by 4.5 equal to sine of b divided by 5. Cross multiply, solve for sine of b, and then take the inverse sine of all that, and we get that b is going to be approximately 70.44 degrees. All right, here, notice how this value here for sine of b, and I'm just writing what it is, putting in the calculator, is 0.9423, and obviously it's less than 1, so that's why we have a b defined, but it's positive. Now think about when sine is positive. Sine is positive on the first and second quadrant, right? We know this from before, so I'm going to have another solution here. We have b is equal to 70.44 degrees as we found using the inverse sine, but I can also have a second quadrant solution, and I will find that by subtracting the 70.44 degrees that we found from 180 degrees to find that second quadrant solution that would also make this equation work, and that's going to be 109.56 degrees. All right, let's make sure everybody has a visual of what we're doing here, how we're finding that second angle. And I'm labeling it as B2, okay? So when you do arc sine, remember arc sine, inverse trig, it always gives you a unique answer. It's always going to be some answer. If it's defined, it'll give you an answer. So that 70.44 is in the first quadrant, and notice how, I'm also using different colors to kind of, make sure you keep track of what we're talking about. The first angle that we found, B in blue there, is in the first quadrant, but sine is also positive on the second quadrant. So that's what I did. I found also the second quadrant angle there, solution, and that B2, hopefully everybody sees why I subtracted it from 180, because B1, the one in blue, it's the same thing as that reference angle on the second quadrant. So to find B2, I would just take 180, which is that half a revolution there, minus the B1 to figure out that second quadrant angle. And that's how we got the 109.56. All right, so we're going to have two triangles here, right? And we're going to find one using our B1 and find the other one using our B2. Okay, so I'll go ahead and start with finding angle C, our third angle. Since I already have angle A and angle B now, I can subtract those two from 180 and figure out my third angle. That would be 180 minus 58 degrees minus 70.44, and that gives me a 51.56 degrees. Okay, so now for last thing for this first triangle, I just need to find what side C is. I have my three angles now. I have two sides. Need to figure out that third side, and we set it up since we already found what angle C is, and I'm labeling as C1 to distinguish triangle 1 from triangle 2. One in blue, the other one in green. And we set it up, we cross multiply, we solve for lowercase c, and we get that lowercase c for that first triangle is going to be equal to 4.5 times sine of 51.56 degrees divided by sine of 58 degrees. Putting that in the calculator, we get that that's approximately 4.16 feet. There we have the first triangle there. Now in the same way, we're going to find the second triangle. We're using our B2 here, and I'm doing it here in green. So C2, angle C for that second triangle, is going to be 180 degrees minus 58 degrees minus 109.56 degrees. Okay? And that gives us a 12.44 degrees. And with that, we're going to find a lowercase c for that second triangle. So we set it up the same way. Sine of 58 degrees divided by 4.5 is equal to sine of 12.44 degrees divided by lowercase c. And remember, this is our second triangle, so I'm going to call it C2 here, equal to 4.5 sine of 12.44 degrees divided by sine of 58 degrees. Putting this in the calculator, we're going to get that lowercase c for the second triangle is 1.14 feet. And there we have it. Now, what we really have here is that in this example, we were able to come up with two different triangles, so label it as triangle 1 and triangle 2, where these parameters work, where these measurements work. Okay, so we have two possible triangles for solutions. And notice how one is acute, the other one is obtuse. Okay, here we have a summary of all the possibilities or the scenarios for this ambiguous case, right? Size, height, angle. So it depends on the size and the height. You're either going to have no solution, one solution, or two solutions. All right, guys. One more thing in this section is a formula for finding the area of an oblique triangle. And this formula is going to work when you have two sides and an included angle here, meaning the angle in between those two sides. So if we want to find the area of a triangle lot with two sides of length 24 yards and 18 yards and the included angle is 80 degrees, then we can use this formula. Notice here in the formula, there's three variations, just depends on what they give you. Remember that the letters here are just placeholders to give you the idea or to be able to write the formula, but as long as you have two sides and the angle in between those two sides, you can use this formula. Now, labeling everything that we have, we get that the area of a triangle is 1/2 24 times 18 times sine of the angle in between. Okay, and again, it doesn't matter which direction you have them, as long as you set it up that way. Now, this formula was derived from our geometric formula of 1/2 times base times height, right? So you can think of the base here as 18, our size C, and the height was figured out to be b sine of the angle, 80 degrees. It's derived similarly as we did for the law of sines. But after you plug everything in, you get that the area is approximately 213 yards square. Here's another example where we have an application problem. And the first thing you want to do is get a picture going here, right? And we have on a small lake, you swim from point A to point B at a bearing of 28 degrees east of north, then to a point C at a bearing of 58 degrees west of north. And finally back to point A. Point C lies 800 meters directly north of point A. It's very important. Approximate the total distance that you swim. So here we have a picture. We already have the angles, the bearings labeled and everything with the sides that we have. Make sure you remember to put the bearing always comes off of the vertical, whether that's north or south, right? Using our geometry here, this 28 is the same thing as that angle there. It's called alternate interior angles. And so having that 28 in there, we know that whole half a revolution is 180 degrees. So I can figure out this angle inside the triangle here, right? So take 180 and subtract 58 degrees and 28 degrees from 180. I get that this angle is 94 degrees. All right, so you had to use a little bit of your geometry knowledge to get that, but we needed that second angle there to be able to apply law of sines here. Because now this becomes a angle side case, and we can use our law of sines to get that. Okay, we're gonna need all three sides of this triangle because we need to add the sum of the three. They're asking us to approximate the total distance that we swim. So first thing that we need is this angle, third angle. Since we have two, we can figure out the third angle by subtracting 23 degrees and 94 degrees from 180, and you can quickly figure out that angle C is 58 degrees. Having that, we can set up our law of sines here, and notice how they've labeled the vertices of the triangle as ABC, so that's nice to be able to refer into our formula. We have sine of b over lowercase b, which is given for us, is 800, is equal to sine of angle C, which is 58 degrees over lowercase c. So I'm going to label those sides in here because we're going to need all three sides. We have one, it's 800 meters, but we're going to need, I'm going to start by finding lowercase c here, the side opposite to 58 degrees. So we cross multiply, solve for c, put that in the calculator, we get that lowercase c is equal to 680.10 meters. All right. In the same way, we're going to find lowercase a, the side opposite to the 23 degrees. And we set it up by doing sine of 94 degrees divided by 800 equal to sine of 28 degrees divided by lowercase a. Cross multiply, solving for a, we get that a is equal to 800 times sine of 28 degrees divided by sine of 94 degrees. Putting this in the calculator, we get that side A is approximately 376.49 meters. All right, once we have all three sides, just make sure you understand what the question is asking. We want the total distance that you swim, and for that we just need to add all three sides. Right? We're going to add the 800 meters plus 680.10 meters plus 376.49 meters. Adding all those three quantities, we get a total distance of 1,856.59 meters. And there we have it.